In this video, we're going to go over a few indefinite integral problems. So what is the integral of 4 dx? What is the answer for this problem? The antiderivative of a constant, all you need to do is just add an x to it. This is going to be 4x. And you also need to add a c value. Anytime you integrate a function, there's always going to be a constant that you need to add to it. Now, the derivative of 4x is 4. The derivative of any constant is 0. So that's why you always need to add the constant. So what about, let's say, the antiderivative of pi? Let's say it's dy instead of dx. All you need to do is add a y variable to it. It's going to be pi times y plus c. Now what about the antiderivative of e dz? E is a constant, so it's just going to be e times z plus c. Now the next type of problem that you're going to see is when you need to integrate a variable raised to a constant. Let's say x raised to the n. This is equal to x raised to the n plus 1 divided by n plus 1 plus c. So for example, let's say if we wish to find the antiderivative of x squared dx. This is equal to x to the third divided by 3 plus c. The antiderivative of x to the third is x to the fourth divided by 4 plus c. Try this one. What is the antiderivative of 8x cubed? So focus on x to the third power. The 8 is just going to come along for the ride. The antiderivative of x to the third is x to the fourth divided by 4. And now we can simplify it. 8 divided by 4 is 2. So the final answer is 2x to the fourth plus c. Try this one. What is the antiderivative of 5x to the sixth power? So using the same technique, let's add 1 to the exponent and then divide by that result. So this is the answer. Now what about this expression? What's the antiderivative of 7x dx? Well, there is an invisible 1, so we can use the same technique. If we add 1, it's going to be 2, and then divide by it, plus c. So the antiderivative of 3x is simply 3x squared divided by 2 plus c. What if we have a polynomial function? X squared minus 5x plus 6. So you need to integrate each one separately. The antiderivative of x squared is x to the third divided by 3. And for 5x, it's going to be 5x squared divided by 2. And then if you have a constant, just add a variable to it. So this is the answer. For each of these problems, before I begin, feel free to pause the video and work on it. So try this one. 4x cubed plus 8x squared minus 9 dx. So the antiderivative of x cubed is x to the fourth divided by 4. And for x squared, it's x to the third divided by 3. And for the constant, simply add an x to it. And if you could reduce it, go ahead and do so. 4 divided by 4 is 1. So it's x to the fourth plus 8/3 x cubed minus 9x plus c. So this is the answer. Now what about square root functions? What is the antiderivative of the square root of x? If you see a question like this, rewrite it. This is the same as x to the 1/2. Now we need to add 1 to the exponent. 1/2 plus 1 is the same as 1/2 plus 2 over 2, which is 3 over 2. So this is going to be x to the 3/2. And instead of dividing it by 3/2, you can multiply by the reciprocal, which is 2/3. So you can write the final answer as 2/3 square root x cubed plus c. Keep in mind there is an invisible 2 here. Here's another one that you can try. What is the antiderivative of the cube root of x to the fourth? So go ahead and pause the video and work on this example. Now the first thing that we need to do is rewrite it. you can rewrite it as x to the 4/3. Now 4/3 plus 1 is the same as 4/3 plus 3/3, which is 7/3. So once we add 1 to the exponent, it's just going to be x to the 7/3. Instead of dividing it by 7/3, let's multiply it by 3/7, and then add the plus c constant. So the final answer is 3/7 cube root x to the 7th power plus c. Now what about this one? What's the antiderivative of 3x minus 1 squared dx? What would you do in this problem? The best thing to do is to FOIL this expression. 3x minus 1 squared is 3x minus 1 times 3x minus 1. 3x times 3x is 9x squared. And then 3x times negative 1, that's negative 3x. Negative 1 times 3x is also negative 3x. And finally, we have negative 1 times negative 1, which is plus 1. So now let's combine like terms. Negative 3x plus negative 3x is negative 6x. So this is what we now have. The antiderivative of x squared is x cubed divided by 3. And for x to the first power is x squared divided by 2. And for the constant, add an x to it. So now let's simplify. 9 divided by 3 is 3. 6 divided by 2 is 3. And so this is the answer. Let's try this one. 2x plus 1 times x minus 2 dx. So just like the last example, we need to FOIL first. 2x times x is 2x squared. And then 2x times negative 2, that's negative 4x. 1 times x is x. And then 1 times negative 2. Now, negative 4x plus x is negative 3x. So now let's integrate it. This is going to be 2x cubed divided by 3 minus 3x squared divided by 2 minus 2x plus c. And this is the answer. We can't really simplify it, so we're going to leave it like that. Let's try this one. X to the 4th plus 6x cubed divided by x dx. What should we do here? What would you do in this problem? Now, if you have a fraction with a single term in the bottom, separate it into two smaller fractions. So x to the 4th divided by x is x cubed. 6x cubed divided by x is 6x squared. And now, as you can see, it's fairly easy to find the antiderivative. So this is going to be x to the 4th divided by 4 plus 6x cubed divided by 3 plus c, which we can write it as 1/4 x to the 4th plus 2x cubed plus c. What about this one? What's the antiderivative of 1 over x squared dx? How can we integrate this function? For fractions like this, you want to rewrite it. If you move the x variable from the bottom to the top, the exponent is going to change sign. It's going to change from positive 2 to negative 2. And now you can use the power rule. So if we add 1 to negative 2, and then divide by that result, this is going to be x to the negative 1 divided by negative 1 plus c. Now we can rewrite it. We can move the x back to the bottom. So the final answer is negative 1 over x plus c. Now let's try another one like that. Try this one. 1 over x cubed. So first let's rewrite it. This is x to the negative 3 dx. And now let's add 1 to the exponent. Negative 3 plus 1 is negative 2. Divide by that result, and you should get this. Now let's rewrite it. So we have a negative in front. We have a 2 on the bottom. Let's keep it there. And we're going to move the x to the bottom as well. So the negative 2 is going to change to positive 2. So it's negative 1 over 2x squared plus c. Now let's try this one. 5 divided by x to the fourth. So first, let's rewrite it. This is 5x to the negative 4. And then let's add 1 to the exponent. So negative 4 plus 1 is negative 3. And then divide by negative 3. And then we'll move the x back to the bottom. So it's negative 5 divided by 3, x cubed plus c. Now what is the antiderivative of 1 over x? If we try to rewrite it, and if we add 1 to the exponent, this is going to be negative 1 plus 1 is 0. And if you have 0 on the bottom, it's undefined. So this is not going to work. For now, you just want to know that the antiderivative of 1 over x is ln x. Likewise, let's say if you want to find the antiderivative of 1 over x minus 3. This is simply ln x minus 3. The antiderivative of 1 over, let's say, x plus 4. This is just going to be ln x plus 4. Now what about this one? What's the antiderivative of 5 over x minus 2? If you want, you can move the constant to the front. So this expression is equivalent to 5 times 1 over x minus 2 dx. And this portion is equal to ln x minus 2, and just multiply it by 5. So this is the answer. Now let's move on to exponential functions. What is the antiderivative of e to the 4x? If it's e to the some number x to the first power, here's what we need to do. It's just going to be e to the 4x divided by the derivative of 4x plus c. If it's like x squared on top or x cubed or something else, it won't work. It only works if the exponent is a linear function. So if you want to find the derivative of e to the 5x, it's simply going to be e to the 5x divided by 5. So what about e to the x? It's going to be e to the x divided by the derivative of x, which is 1, plus c. So the antiderivative of e to the x stays the same. It's just e to the x. Now let's try a few more examples. Try these two. 8e to the 2x, and also 12e to the 3x. So this is going to be 8e to the 2x divided by the derivative of 2x, which is 2. And that reduces to 4e to the 2x plus c. For the last one, this is going to be 12e to the 3x divided by 3 plus c. And that reduces to 4e to the 3x plus c. Now let's move on to trig functions. What's the antiderivative of cosine x dx? Now think backwards. The derivative of what function is cosine? The derivative of sine is cosine, so the antiderivative of cosine is positive sine. Now what is the antiderivative of sine? The derivative of cosine is negative sine, so the derivative of negative cosine is positive sine, which means the antiderivative of positive sine is negative cosine. So let's say if we want to find the antiderivative of cosine 3x. This is going to be sine 3x. The angle has to stay the same, but then divided by the derivative of 3x, which is 3. This works is only if you have a linear function on the inside. Can you use this technique? So for example, the antiderivative of cosine 7x is simply sine 7x divided by 7 plus c. Now what is the antiderivative of 14 sine 2x? So this is just going to be 14. The antiderivative of sine is negative cosine 2x, but divided by 2. So we can reduce that to negative 7 cosine 2x plus c. 14 divided by 2 is 7. Let's try this one. 6 sine 3x dx. The antiderivative of sine is negative cosine 3x, but divided by 3. So the final answer is negative 2 cosine 3x plus c. 6 divided by 3 is 2. Now what is the antiderivative of secant squared dx? The derivative of tangent is secant squared, so the antiderivative of secant squared is simply tangent x. So if we want to find the antiderivative of 8 secant squared 4x, this is going to be 8 times tangent 4x, but divided by 4 plus c, which becomes 2 tangent 4x plus c. Now what is the antiderivative of secant x tangent x? The derivative of secant is secant tangent, so this is equal to just secant x plus c. So if we have the antiderivative of 12 secant 3x tangent 3x, this is equal to 12 secant 3x divided by 3 plus c, which is just 4 secant 3x plus c. Now, what if you were to see an expression that looks like this? What is the antiderivative of x squared sine x cubed dx? What would you do in a problem like this? Now, there's a technique called u substitution, and you want to replace all the x variables with u variables. I'm going to make u equal to x cubed. The reason being is the derivative of x cubed is 3x squared. And the 3x squared in this expression can cancel with the x squared in that expression, which is what we want. Now, in the next step, solve for dx. Du divided by 3x squared is equal to dx. So what we're going to do is replace x cubed with u and dx with du divided by 3x squared. So this is going to be x squared sine u du over 3x squared. So notice that the x squared cancels. And let's take this constant and move it to the front. So what we now have is 1/3 antiderivative sine u du. And we know what the antiderivative of sine is. It's negative cosine. So this is negative 1/3 cosine u plus c. Now at this point, all you need to do is replace the u variable with what it was in the beginning, x cubed. So the final answer is negative 1/3 cosine x cubed plus c. Let's try another u substitution problem. Try this one. Do you think we should make u equal to x squared plus 3 or 5x? Notice that the derivative of x squared will give you 2x, which can cancel the x and 5x. So you want to make u equal to x squared plus 3x. So du is going to be 2x dx, and then solve for dx. dx is du divided by 2x. Now we need to replace x squared plus 3 with u and dx with du over 2x. So this is going to be 5x raised to the u, or times u raised to the 4th power, and then times du divided by 2x. So we can cancel the x variable, and the constant 5 over 2, let's move it to the front. So let's put it on the left side of the integral. So this is 5 over 2 u to the 4th du. Now we can use the power rule. So if we add 1 to the exponent, it's going to be u to the 5th divided by 5 plus c. So notice we can cancel these 5's. So what we now have is 1/2 u to the 5th plus c, which is, let's make some space. At this point, we can replace u with x squared plus 3. So the final answer is 1/2 x squared plus 3 raised to the 5th power plus c. So this is it. Now let's try this problem. What is the antiderivative of tangent x? You can either know this answer or you could find a way to get the answer. So what can we do? Now tangent is sine divided by cosine. So in this form, we could use u substitution. Let's replace u with cosine x. If we do that, the derivative of cosine is going to be negative sine. And if we solve for dx, it's going to be du divided by negative sign. Notice that the sign variable will cancel. So let's replace cosine with the u variable, and let's replace dx with du divided by negative sign. So the expression that we now have is the antiderivative of negative 1 over u. If you recall, the antiderivative of 1 over x is ln x. So for 1 over u, it's ln of u. Now we can replace the u variable with cosine. So what we now have is negative ln cosine x. Now there's a 1 in front of here. A property of natural logs allows you to take the coefficient and move it inside of ln. So this is going to be ln cosine x to the negative 1 power plus c, which is the same as ln 1 divided by cosine x. Now 1 divided by cosine is secant, so the final answer is ln secant x plus c. That is the antiderivative of tangent x. Now what if you were to see this? What is the antiderivative of x cosine x dx? We can't really use u substitution here. The derivative of cosine is negative sign. That's not going to cancel the x. So u substitution won't work. There's something else called integration by parts. And here's the formula. The integration of u dv is equal to uv minus the antiderivative of v du. Let's make u equal to x. So this is the u part. dv, we're going to make it equal to cosine x dx. Now we need to find du and v. Du is the derivative of u, so the derivative of x is 1. V is the antiderivative of dv. The antiderivative of cosine is sine. So this is going to be u times v, that's x times sine x, minus the antiderivative of v du, which is simply sine x. Oh, let's not forget dx is here. Du is 1 dx. And u dv is basically the original function. Now all we need to do is find the antiderivative of sine. The antiderivative of sine is negative cosine. So we have the final answer. It's going to be x sine x plus cosine x plus c. Let's try another integration by parts problem. Try this one, x e to the 4x dx. So you want to make u equal to x because when you find du, the x is going to disappear. d is going to be 1 dx. Now we're going to make dv equal to e to the 4x because we know how to find the antiderivative of e to the 4x. E to the x and sine x, they're basically repeating functions. The antiderivative of e to the 4x is e to the 4x divided by 4. So using the formula, antiderivative u dv is uv minus antiderivative v du. So uv is basically x times 1/4 e to the 4x. So that's 1/4 x e to the 4x minus the antiderivative of v du, which is simply 1/4 e to the 4x dx. So the antiderivative of e to the 4x is just e to the 4x divided by 4, and then plus c. So now we could write the final answer, which is 1/4 x e to the 4x minus 4 times 4 is 16, so 1/16 e to the 4x plus c. So that's integration by parts. Let's try this problem. what is the antiderivative of 4 divided by 1 plus x squared dx? Now in this problem, we can't really use substitution, and we can't use integration by parts. So what can we do here? Now another technique that you can use is trigonometric substitution. It helps to know that 1 plus tangent squared is equal to secant squared. So notice the expression 1 plus x squared. That is an indication that we should make x equal to tangent theta. If x is tangent theta, x squared is going to be tangent squared. And dx is the derivative of tangent, which is secant squared d theta. So let's replace x squared with tangent squared. And let's replace dx with secant squared theta d theta. So now 1 plus tan squared we know is secant squared. And the secant squareds cancel in this problem. So what we now have is the antiderivative of 4d theta. The antiderivative of 4dx is just 4x. So 4d theta is simply 4 theta plus c. So now we need to replace theta with something in terms of x. If x is equal to tangent theta, then the inverse tangent of x is equal to theta. Whenever you're dealing with an inverse function, you need to switch x and y. In this case, x and theta. So the final answer is 4 inverse tangent of x plus c. We just need to replace theta with inverse tan. So this is it. Let's try this one. Now, sine squared plus cosine squared is equal to 1. So 1 minus sine squared is equal to cosine squared. So this is another trigonometric substitution. And based on that identity, we want to make x equal to sine. So if x is equal to sine theta, x squared is sine squared theta, and dx is the derivative of sine. It's going to be cosine theta d theta. So let's replace x squared with sine squared. And let's replace dx with cosine theta d theta. So we know that 1 minus sine squared is equal to cosine squared. And the square root of cosine squared is simply cosine theta. So at this point, we can cancel the cosine function. So the expression that we have now is simply the antiderivative of 3d theta, which is equal to 3 theta plus c. So now our last step is to replace theta with something. So if x is equal to sine theta, what we need to do is take the inverse sine of both sides. The inverse sine of sine theta is simply theta. These two cancel. So inverse sine x is equal to theta. So the final answer is 3 inverse sine x plus c.